Hello my dear students, welcome back. It's so good to see you. How was the quiz? Not bad, wasn't it? I'm so glad to hear this. I'm so glad that you're doing your quizzes. It's so important, alright? For you to understand what Mr. Mac is teaching you, you gotta have some hands-on. Not only hands-on practice with Mr. Mac, but you also have hands-on on your own. So this way gives you confidence on what you learn. Okay, good. In this sub-lesson, we're going to talk about equivalent fractions. What is equivalent fractions? Okay, let's talk about it. Okay, let's say for example, I have a pizza. So now I invited you over. So we're going to have a pizza. So what we're going to do? We're going to eat equally, but right? We're going to cut it into half. Alright, so we're going to cut it right equal size half. So we know this is 1 over 2, 1 over 2. How is that? Because in one whole pizza, we cut it into two pieces. See that? That's what this 2 represent. We cut it into two pieces, and then 1 represents the one of the two pieces, and then one of the two pieces. See that? That's what 1 over 2. Now, so we enjoyed the one big half of the pizza. See, that's a big pizza, am I right? For both of us to enjoy it. Okay, good. Now, we're going to invite another 2 more. So what's going to be? 4 of us. So what I have to do now? I have to cut the pizza into how many pieces? 4 pieces. Now look at that. The same one whole pizza, I cut it into 4 pieces. That way, 4 of us can have it. So what that makes? 1 over 4, 1 over 4, 1 over 4, 1 over 4. Again, a whole pizza, we cut into 4 pieces. That's what the denominator represents. And we just need, each of us just get 1 piece, only 1. Now, what happened that another 2 more people that we invited didn't show up? Which is good, isn't it? No, actually, well, they didn't show up. Actually, I know something like that. It's good, isn't it? Because we're going to have you got 2 pieces, I got 2 pieces. See that? Well, earlier we only got 1 pieces each. This time we got 2 pieces each. But wait a minute. That 2 pieces that I'm referring is the same as the half of the whole pizza, which makes 1 piece. See that? So which still makes what? Half of that pizza. You get half of this and I get half of that. Even though I get 2 pieces and you get 2 pieces, but each of the 2 pieces represent what? 1 over 4, 1 over 4, which is what? 2 over 4, which is also 1 over 2. See that? That means the half of the pizza, which is in this case, which is you get half on this one when we only have 2 people for you and me to share with. So you get half, I get half. So that's half. But we invited 2 more, so we had 4 people, but they didn't show up. So we got to eat the 2 pieces you, 2 pieces me. See that? But look at that. The 2 pieces that you had and 2 pieces I had represent what? 2 over 4 and 2 over 4. Okay? So that means what? It's still the half. So in other words, 1 over 2, it still equals to 2 over 4. See that? The half of the pizza. And that's the equivalent. Now let's say for example, this time we invited another 6. In other words, altogether 8 of us. Alright? So what I have to do with the one whole pizza? I have to cut it into 8 pieces. Okay? So now I got one whole pizza. Okay? Same size. And I cut it into 8 pieces. Okay? So that means, see that as the denominator get bigger, what happened to the size of the pizza gets smaller. See that? So now look at that. This is 1 over 8, 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 and 1 over 8. So, how do I get 1 over 8? Because there are 8 pieces in one whole pizza. See that? That's what the denominator represents 8. And 1 represents the numerator, 1 over 8. Now let's say for example, the 6 people we invited didn't show up. We got to eat 4, let's see, 1, 2, 3, 4, 4 pieces this side and 4 pieces. So you gotta have 4 pieces, I gotta have 4 pieces. Wow, 4 pieces? Earlier we only had 1 pieces and then 2 pieces, now 4 pieces? But look at that. That 4 pieces that I'm referring it's right there. 1, 2, 3, 4. Still makes it what? Half. 1 over 2, the same thing. Except in this time I had that half of the pieces cut into 4 pieces. Because the whole pizza was cut into 8 pieces, because we were anticipating how many altogether? 8 people to show up. 6 didn't show up. You and me got to share all the 8 pieces. You take 4, I take 4. See that? So that's what this is. So 1, 2, 3, 4. So that means 4 over 8. 1, 2, 3, 4. 4 over 8. So you have 4 over 8 and I have 4 over 8. But wait a minute. 4 over 8, which is makes this right there. That means it's half the pizza. Still half the pizza. Exactly. The thing is, in this case, I cut it into half and I had the whole thing. It's like a one big piece. Really like that. But this one was cut into 8 small pieces and I got 4 small pieces. See that? So this way I can take this one, eat 1, eat 2, eat 3, eat 4. But still I had half and you have half. See that? In this case, one whole half. In this case, it was broken up into 4 parts, which total up to half. See that? That means what? 4 over 8 is also equals to 1 over 2, which is also equals to what? 2 over 4. See that? This is what we call equivalent fractions. Okay? Because why? When you simplify 4 over 8 will come to 1 over 2. When you simplify 2 over 4 will come to 2 over 4. What do I mean by that? Simplifying. I can take, let's say take 4 over 8. I find a common number that I can divide 4 and 8 with. What would be the common number I can divide 4 and 8 with? Which is the 4. Because 4 divided by 4 is 1. 8 divided by 4 is 2. Look at that. Back to 1 over 2. Now if I want to go the other way around, if I have 1 over 2, I want to go the other way around, I multiply. I can multiply. Now keep in mind, when you have this line, this is a dividing line or overline of the fraction. And you have a numerator and denominator. You can only divide or multiply. You cannot add or subtract. What do I mean by that? I can multiply as long I multiply numerator and denominator with the same number. Okay, the same thing. Or I can divide as long I divide that with the same number, with the numerator and denominator. I can't just simply divide this by 2 and divide this by 4. I can't. I have to. If I divide the numerator by 4, I have to divide the denominator by 4. If I multiply the numerator by 3, I have to multiply the denominator by 3. So that makes it what? 3 over 6. Okay, so we'll represent that in the pizza. Okay, we'll look at the 3 over 6, but I want you to make sure you understand this. Numerator and denominator, you can multiply, you can divide, but you cannot add. You cannot add or subtract. Okay, or subtract. You cannot do that. Alright, even though the same numbers, adding or subtracting, numerator and denominator, you can do that. Only dividing up numerator and denominator, or multiplying numerator and denominator, you can do that. Okay. See that? So when I multiply the half with 3 and 3, it becomes 3 over 6. Now let's put that in the form of pizza, okay? One whole pizza, okay? How many is it cut into? Into 6 pieces, okay? So we've been cut into 6 pieces. So let's see. 1, 2, 3, 4, 5, 6. See there? We got 6 pieces, alright? And how many? 3 over 6. Let's look 3 over 6. So 1, 2, 3. Look at that. So you get 3 over 6, I get 3 over 6. Look at that, that is still what? Half of the pizza. And I also get half of the pizza. On this side, 3 over 6. That makes sense? And that's what called equivalent fractions. Okay? So I can expand 1 over 2 to any form of fraction which is equal to 1 over 2, okay? Which I can reduce. What I mean by eventually, when I reduce it down, it will back to 1 over 2. So in other words, I can take 1 over 2, I can multiply that by 5, multiply this by 5. Very important. If I multiply numerator by 5, what do I have to do with the denominator? Exactly, I have to also multiply that by 5. Okay, because 1 times 5 is 5, 2 times 5 is 10. So now this tells you, out of the 10 pieces, out of one piece, I cut it into 10 pieces, you get 5, I get 5. See that? 5 plus 5 is what? 10. 10 over 10 is 1. Okay? So another thing I want you to keep in mind, if you have a 1 over 2, 1 over 1, this can be represented in any form, like a 9 over 9, or 100 over 100. Okay? So 1 can be expressed in any form like this. Keep in mind, okay? Equivalent fraction. Alright, so you see that? So in other words, if I have 3 over 4, if I want to find the equivalent fraction of that, I just multiply. Like say for example, I want to find the equivalent fraction of 12. So 4 times what gives me 12? Times 3, am I right? That means 3 times 3. Because I multiplied this by 3 to get to 12, I have to multiply 3, the numerator by also by 3, so which give me 9. See that? Now what about if I say 3 over 4 and I put in a form 16 and I want to find out what that number would be. Now how did I get from 4 to 16? What do I multiply that with? 4 by 4. 4 times 4. Okay? So if I multiply this by 4, what do I have to do with the numerator? Also multiply that by 4. So 4 times 3 is 12. And 3 over 4 is equivalent fraction to 12 over 16. See that? Pretty easy, isn't it? Okay, so make sure you understand the word equivalent fraction. Okay? So that's what it means. That's what's all about equivalent fraction. Okay, good. Let Mr. Mac erase the board. Let's talk more about equivalent fraction. Okay? I'll be back, my dear student. Alright, my dear students, so now you understand what is equivalent fractions all about, okay? So now let's say for example, if I give you something like this, if I say 3 over 5 and I want to find what would be here if I would have given you this 15. So how do I get from 5 to 15? I multiply that by 3. See that? If I multiply this by 3, what do I have to multiply that by? Also 3. Very important. So that makes it 3 times 3 is 9, because 5 times 3 is 15. So 3 over 5, it's equal, it was equivalent fraction to 9 over 15. Okay? Now let's say for example, if I had given you 16 over, let's say 18, and I want to find the equivalent fraction, let's say for example 9. So what would be this one? Ask yourself, how did I go from 18 to 9? I divide this by 2, because 18 divided by 2 is 9. If I divide the denominator by 2, what I have to do to the numerator? Also divided by 2. It's very important. You got to be consistent. Okay? I can't divide denominator by 2 and then numerator by 4. You can't do that. They has to be same. So in this case, 16 divided by 2 is 8. So 16 over 18, equivalent fraction is 8 over 9. Okay? So keep that in mind. Now let's say for example, if I give you two fractions, I tell you 3 over 4 and let's say 8 over let's say 10, and I want to find out which one is bigger, are they equal, are they bigger, which one's bigger or smaller, things like that. How do I do that? Only way to compare two fractions to have the denominator to be same. There's no way to compare it, okay? It'll be very difficult. Okay, if it's a simple number like this, you can. Let's say 1 over 2 and 3 over 4. Alright, but it's always advisable. You always make the denominator as a common denominator. Okay? Then compare it. Okay? So what do we do? We're going to find the lowest common denominator between 4 and 10. Of course, right away you'll think 4 and 10 would be 40, would be, no, that's not the lowest. How about 20? 20 would be the lowest, okay? So why 20? Because 20 can be divided by 4, 20 can also divide by 10, okay? Like we learned from our previous lesson. The lowest common denominator for 4 and 10 would be 20, okay? So that means we're going to put 20 and 20. Now how do I get from 4 to 20? I multiply that by 5. That's right, I multiply 4 by 5 and to get to 20. If I multiply 4 by 5, what do I have to multiply 3 with? Also 5, exactly. So that makes it 15 over 20. That's the equivalent fraction. From 3 over 4 is equal to 15 over 20. I didn't modify the value. It's just that I expressed in different form. Just like you. One day you dressed up so awesome, you know, then another day you dressed up a lot awesomer, but it's still you, isn't it? I mean, I shouldn't say, I mean, you dressed up one day with different clothes and the next day with another clothes, but still it's you, the same thing, okay? The 3 over 4 is still 3 over 4, but in a different form, a dress or something like that, clothes, okay? Alright, so now, how about 10? How do I get from 10 to 20? I multiply that by 2, see that? 10 times 2 is 20. That means 4, I also multiply that by 2. Exactly. So 8 times 2 is 16. Now look at that. 20 and 20. The common denominator. Okay. So which one's bigger? Of course, this one. The 16 is bigger than the 15. Once you made them into common denominator, now it's a lot easier by looking at 15 and 16 to tell which one is bigger. By looking like this, there's no way to tell, because it could be 3 over could be bigger, or it could be 8 over 10. We don't know yet. See that? Okay, good. So this is how you do it, alright? Okay, good. Now, for example, this one. Which one is bigger? Of course, we know because it's a simple fraction, because we know half, and also comparing to 3 over 4, this is going to be bigger, alright? But still, we don't want to do that. We want to make them into common denominator. So what would be the common denominator between 2 and 4? Very good. The lowest common denominator would be 4. Okay? Because 4 can be divided by 2. 4 also can be divided by 4 itself. See that? That's why you want to pick 4. Okay? So I'm going to put 4. How do I get from 2 to 4? I multiply that by 2. That means I'm going to multiply this by 2. That means the numerator also multiplied by 2. Okay? So 1 times 2 is 2. And this one is still the same. I just bring the 3 down. Now who's bigger between 2 and 3? Of course 3 is bigger right there. See that? Pretty easy, isn't it? In comparing two fractions, that's how the equivalent fraction comes so handy. Very important you understand that, okay? Let's do another one. Let's say, for example, this time I give you 5 over, let's say 7, and then let's say 8 over 14. And I'm trying to figure out which one is. Let's do 9 over 14. Okay, that's a good one. All right. Okay, so we want to find out which one is bigger. Okay, so look at that. 7 and 14. They're not common denominators. No way. You can't just say 9 is bigger. There's no way you can do that. Why? Because the denominators are not common. You have to make the denominators common. Let's say, for example, we just guessed, well, 9 is bigger than 5. So I'm going to say this. Alright, by just guess, which you're not supposed to do in mathematics. Never ever guess, okay? Because there's always a way to solve it, to get to the answer. That's what mathematics is all about. If everything you want to be guessed, can you imagine that? The building, the architects will all be guessing, will be like walking to a building like this. Because all the floors won't be even, you know, and then the cars will be like, you know, because the engine won't be running right. Next, because they're all rubbing each other, and then the seats won't be comfortable. See that? Because all involve mathematics. I know. See that? You can't guess. If everything has been created by guessing, what happens? We are in big trouble, alright? Okay, good. Come back here. Okay. So what do we have to do? We have to do a common denominator, okay? Between 7 and 14. What would be the common denominator? The lowest common denominator, 14. Very good. Always say between these two numbers, can they be a common denominator first before you look for another number, okay? Which is 14 could be the common denominator. So how do I go from 7 to 14? I multiply that by 2. If I multiply this by 2, the denominator, I have to multiply the numerator also by 2. Very good. 5 times 2 is 10. And since this one's already 14, and that's 14, I just bring the 9 down. Alright? Now look, who's bigger? This one is bigger. Oh, see that? Oh, that was wrong. Bad way to guess. See that? I told you? We can just simply guess. Mathematics, you got to solve it. This is the way. Okay? You cannot look by feeling it or say, I feel like 9 is bigger than 5, so I'm just going to go with that. You can't do that. See, look at that. It proved it. Guessing is not the way to do it. Alright? Okay, good. Alright, my dear students, I'm so proud that you're learning so much, okay? Because why? Because you're the best. And you only deserve the best. And that's the next year to only bring the best for you. And it is coming from the best. It is. And I'm here for you. I am here. And I always want to give you the best. Because you deserve the best. Alright? Okay. Let Mr. Mac erase the board and we'll do some hands-on practice. We call Pablo out. Okay? And I'll be back with you in a few seconds. Alright, my dear students. You ready for some hands-on practice? Good. Well, let's call Pablo. He's busy putting some questions together. Let's call him. So before you give me too many questions, actually it's good, isn't it? Alright, okay. Well, let's call him anyway, okay? Pablo, come on over. Our students are ready. Come on over. There he is. All right, my dear students, he's going to hand over a worksheet, hands-on practice worksheet to you. And guess what? Have fun with it, okay? And then go ahead, pause the video, okay? Have fun, and once you're done, invite Mr. Mac in, and then we'll work together, okay? And here it is. Have fun. Go get him. Okay, good. All right, so, whoa, he gave you 4 questions. Not bad, isn't it? All right, let's do it. The first one. The first question says, find the lowest terms for the following fractions. Okay, that means what are you trying to do? You're trying to simplify, or you're reducing it to the lowest equivalent fraction. All right, so you're given like a 16 over 24. So let's write that down. 1a. You're given 16 over 24. Actually, what you're trying to do is you're finding the equivalent fraction in the lowest form. Okay, so what would be it? The lowest. So you want to find a number, the biggest number, all right, the highest common number that you can divide 24 and 16 with. So let's start with, let's see, 16 and 24. Why does it look very common to you? 4. Now even if you didn't, let's say you start with 2, doesn't matter, you can start with 2. Okay, 16 divided by 2 is 8. 24 divided by 2 is 12. Okay, now look and see, can you simplify this any further? Yes, you can divide that by 2. Alright, again another 2. Alright, so then 8 divided by 2 is 4. 12 divided by 2 is 6. Can we divide more? Yes, we can divide that by another 2. See that? 4 divided by 2 is 2, and then 6 divided by 2 is 3. So 2 over 3. And that's the simplest equivalent fractions. See that? Now this is all an equivalent fraction also, but they want the lowest term. And that would be the lowest term, because come to the prime number, such a way you cannot divide anymore. Alright? So not necessarily has to come down to prime number, such a way that numerator and denominator doesn't have a common number, okay, that you can divide that with. But in this case, look at that, 4 over 6, 2 can be divided. 8 over 12, 2 can be divided. Now, let's say for example, we can bypass all this if we know a number that 16 and 25 can be divided by. How about 8 from our timetable? We know that 16 can be divided by 8 because why? 8 times 2 is what? 16. Okay, so I can divide this by 8, and also 24 by 8 because 8 times 3 is what? 24. So 16 divided by 8 is 2, 24 divided by 8 is 3. See that? We straight went to the answer. So we bypassed that. Okay, now to get you started, you can do this way, but I would recommend, because of the time constraint, all right, you have to be using this approach. Okay, because why? Because you belong to Score A Math Victory. This is Score A Math Victory's approach. All right, and that's why we kind of learned from the previous lesson how to find the common, the most common, okay, number. How do we do that? How do I find that? You use what method do we use? The ladder method, the one-leg ladder method. Remember the one-leg ladder method? You put 16 and 24, and you divide that by, start with 2, and this one becomes 8, and this one becomes 12. And divide this by 2, and this one becomes 4, and this one becomes 6. And you divide this by 2, and this one becomes 2, and this one becomes 3. And you can't divide this any further. So this would be the common divider for 16 and 24. So 2 times 2 times 2 is 8. Right there. Alright? Okay? So 16 divided by 8 is 2, 24 divided by 8 is 3. And that's how you do it. Alright, good. Now let's look at another one. The next one is B. B got 25 over 30. So we want to find a common number that can be divided by 25 and also with 30. What would that be? Now whenever you see a 5 and a 0 in the back, the number that should come to your mind that you can divide both with would be 5. Okay? Alright, 5. So you can divide 25 by 5 and 30 by 5. 25 divided by 5 is 5. 30 divided by 5 is 6. Can I divide this any further? No. Now look at that. This is not a prime number. Okay? So not necessarily has to be a prime number, then only you can stop. But see that? The reason why we couldn't reduce this down any further is 5 and 6 doesn't have a common number that I can divide both of. they're pretty much done. See that? Okay, that means this is the lowest term, okay, on the fraction. You can bring it down to, you can simplify it to. Okay, good. Let's look at C. The C gave you 27 over 45. Now look at it. This one is 5, but this one is 7. So you know 5 cannot do it. But from our timetable, what 27 and 45 can divide by? See that how timetable comes into play? That's why I want to make sure that you know your timetable. By now you should be, because we already talked about from the previous lesson. You got to have your timetable in your fingertips. Alright? When I want to ask you anything about timetable, you'll be like what? Like at the Wild Wild West. Always be ready. You have your boom, 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 boom. See that? Okay, be prepared. And that's your timetable ought to be like that. You always be prepared. Have it in your belt. When somebody asks you, 7 times 4, 28. 7 times 5, 35. See that? 6 times 4, 24. 3 times 7, 21. 7 times 7, 49. 6 times 8, 42. See, wrong. 6 times 9, 54. See that? And 6 times 8, 48. Okay, good. So it's very important. You gotta know all this. Okay, good. So now in this case, 27 over 45. So what would be the common that 27 and 45 can divide it by? Exactly from the timetable, 9 timetable, because I can divide 27 by 9, 45 by 9. 27 divided by 9 gives me 3. Very good. 45 divided by 9 gives me 5. Why is that? 3 times 9 is what? 27. 5 times 9 is what? 45. The reverse of that. Okay? And this is the simplest, the simplest fraction, equivalent fraction for 27 over 45. Pretty fun, isn't it? Pretty easy, isn't it? Alright, good. Okay, good. Now let's look at problem number 2. 2a. Now you're given 2a, 2 over 5, and then equals to 8, and then they put a box here. They want to find out what the missing number there. Now in this case, what are we doing? We are increasing it, okay? Earlier we simplified it. This one, we're still finding the equivalent fraction, but in a bigger, alright? In a bigger form. Okay, so how do I go from 2 to 8? I multiply this by 4. If I multiply this by 4, what do I have to do to 5? Exactly, I also have to multiply that by 4. So 5 times 4 is 20. See that? So the equivalent fraction for 2 over 5 is also equals to 8 over 20. Now if I had to use this approach that we learned simplifying, the 8 over 20, so 8 over 20, I find a common number that I can divide 8 and 20 by, which is the reverse of the times of 4. I divide that by 4. See that? Pretty easy, isn't it? Pretty exciting, isn't it? So 8 divided by 4 is what? 2. 20 divided by 4 is what? 5. See, back to that one. So it's just the reverse of that. Now this time we kind of going bigger. Okay, good. Okay, let's look at B. Now B, you're given 4 over 7 equals to, and then we want to find out what would be inside there, over 21. So how do I go from 7 to 21? Exactly, I multiply that by 3. Okay, 3 times 7 is 21. Now, if I multiply the denominator by 3, what do I do to the numerator? Also multiply by 3. So that makes 4 times 3 is 12. So the missing number in that box would be 12. So 12 over 21 is the equivalent fraction to 4 over 7. Okay, good. Okay, let's look at number C. Now C, you're given 11 over 12. And then they give you 72 for the denominator, and they want you to find the numerator. And how do we do it? Very good. 12 times 9 equals to 70. 12 times 6 equals to 72. See that? So if I multiply 12 by 6, what do I do to the 11 also? What do I do to the 11? Also times it with 6. So that makes it 11 times 6 is 66. The missing number in the box is going to be 66. Told you it's very easy. Okay, good. Alright, let Mr. Mac erase the board and we'll do the problem number 3 and 4. Okay? And I'll be back with you in a few seconds. Alright, okay, problem number 3. Which one of the two given fraction is smaller? Always read the question. I didn't ask for bigger, asking for smaller. Okay, so let's write that down. Number 3, A. So we're looking for smaller, which is two fractions are 4 over 9 and 5 over 9. So which one is smaller? Exactly. First check, make sure the denominators are common denominator, okay? Both are common. So that means I can compare 4 and 5 now. So which one is smaller, 4 or 5? Of course 4, am I right? So this fraction is smaller. So it's very important when you want to compare between two fractions, the denominator has to be what? Common. Make sure you convert that into common. So let's look at the second one, the B. The B was given 3 over 5 and 7 over 15. Okay, now am I going to say 7 over 15 is bigger and 3 over 5 is smaller? We don't know. We cannot make that assumption. Okay, why is that? Because the denominators are not common. So I have to make it common. Now look at that, 5 and 15. I can convert this also as a 15 by multiplying 5 by what? 3. So I'm going to multiply this by 3 and this by 3. Okay, so that makes it both going to have same common denominator. Okay, so that makes it 15 over, the numerator is going to be 9 and this one is going to be 7 over 15. See that? If we wouldn't done this, we would have thought this would have been bigger. Am I right? What did I say? Never ever guess that. Actually it turned out to be this one is bigger. This one is bigger. This is the smaller. So the answer is 7 over 15 is smaller. Okay, not 3 over 5. Okay, again, never ever guess. Remember we talked about earlier, all the engineers, all the architects, if they start guessing everything, what's going to happen? The bridge, can you imagine the bridge is going to be like this? Woo, it's going to be fun, isn't it? It's going to be like a roller coaster as you're driving. No, it's not. I'm just kidding. Okay, we don't want that. We will have a road sick. Okay, good. All right, let's get back here. Okay. So see that how important it is? Never ever guess. You got to solve it. Okay. All right. Good. Let's look at the problem C this time. C was given. Okay. Let's see. C was 1 over 2 and 2 over 3. Okay. What do? Both are not common denominators. Okay. So I want to find the lowest common denominator between 2 and 3. What would be the lowest common denominator for 2 and 3? Exactly, 6. How do I know 6? Because 2 can be divided by 6 and then 3 can be divided by what? How do I know 6? Because 6 can be divided by 2, 6 can be divided by 3. Okay, so that would be the lowest, because one way of doing it is multiplying 2 by 3 give me 6. And think about it, is there anything smaller than 6 that 2 and 3 can be divided by? No, 6 would be the right number. Okay, so we're going to put this as 6 over here. So how do I go from 2 to 6? I multiply this by 3. If I multiply the denominator by 3, I multiply the numerator also by 3. So it becomes 3 over 6. And I also make 6. How do I go from 3 to 6? Multiply that by 2. So if I multiply the denominator by 2, numerator also by 2. So 2 times 2 is 4. So who's smaller and who's bigger? This one's bigger and this one's smaller. The question asking us, find the smaller. Okay, and this is smaller. You circle the smaller one. Alright, it's very important. Okay, alright, good. So now let's go to the D. Now D were given 6 over 7 and 2 over 3. Okay, again, what do? We find the common denominator. Okay, what's the common denominator between 7 and 3? One quick way of doing it is 7 times 3 is 21, and then trace it back. 21, is there anything other than 21 smaller than 21 that 7 and 3 can fit in from the timetable? So you came through your timetable. Nope, that thing. Alright, okay, that means 21 would be the lowest common denominator, okay, for 7 and 3. So we're going to put 21 and 21. How do I go from 7 to 21? By multiplying that by 3. If I multiply the denominator by 3, I multiply the numerator also by 3. 6 times 3 is 18. And how do I go from 3 to 21? I multiply that by 7. If I multiply the denominator by 7, what do I do to the numerator? Also by 7. Very important, okay? Very important. You got to treat them equally, okay? So 2 times 7 is 14. Alright, so now look, 14 and 18, who's bigger? 18 is bigger, so our answer ought to be the one smaller, so which is this. So that's the smaller. 14 over 21 is the smaller. Okay, good. Alright, let's look problem number 4. The problem number 4 says arrange the fractions below in increasing order. Okay, so we were given, so 4a, we were given 11 over 12, 2 over 3, and 3 over 4. How do we do this? Good job, very good. You find the common denominator, the lowest common denominator for all 3 of them, and make that was the best way to compare them. Okay, so in this case, looks like 12 would be the lowest, because 3 can get in 12, 4 can get in 12, and 12 can get in itself. You see that? So 12 will be the perfect, so we're going to make all of them to be 12. Okay, so since this is 12, I will just bring the 11 down. And how do I go from 3 to 12? I multiply that by 4. Okay, if I multiply this by 4, what do I do to this one? Also by 4. So 2 times 4 is 8. How do I go from 4 to 12? Multiply that by 3. If I multiply this by 3, I multiply that also by 3. So 3 times 3 is 9. Now can I arrange them in an increasing order? Okay, increasing, or another word is ascending order. Okay, ascending, increasing and ascending are same, kind of like the aeroplane. Okay, so when the aeroplane is ascending, it goes up like this, so that the height is from small get bigger. Okay, so that's ascending, which is also increasing. Descending is a landing. Okay, it's from the top, so that it's on the air, and then it's trying to land to the airport. See that? From the big number it gets smaller. So that's ascending, okay? That is descending, and this is ascending, okay? So in this case, increasing, I can use the word increasing, which is also means ascending, alright? If I say decreasing, which is descending, okay? Good. Alright, so now once we get all that in a common denominator, so now I can tell which is the smallest, because we're going to go what? The increasing, we're going to start with the smallest, okay, which would be 8 over 12. And then the next one would be 9 over 12, and then the biggest would be 11 over 12. See that? It's increasing, ascending. Okay, good. Now let's look at B. Now B, we were given 23 over 30, 4 over 5, 7 over 12. It's so tempting to say right away, this got to be the biggest. Is that how we do it? No! I know you're saying, Mr. Mac, that's not the way to do it. Why? That's a guessing. Alright, that's a guesswork. We don't do guesswork here. Why? Because we are Score Math Victory students. Score Math Victory always solve the problem, do it right way, and that's for who you are. Because you're Mr. Mac's proud student. Alright? Okay, so we're going to find the common denominator for 30, 5, and 12. Okay? Well, 5 can fit in 30, but 12 cannot. Okay? So we're going to find a common for 30, 5, and 12. How do we do that? We use the one-leg ladder method. Alright? That's where it comes in, one-leg ladder. You put the 30 in there, you put the 5 in there, and 12 in there. Okay? So you divide until you come to 1, 1, 1. That's the key, okay? The key behind finding a common denominator for these 3 numbers would be you divide them, okay, until at the end would be 1, 1, 1. Alright, so we're going to start with 2. Let's start with 2. So 30 divided by 2 is what? 15. You cannot divide 5, so you bring the 5 down. 12 divided by 2 is 6. Can I still do 2? Always start with a small number is best, okay? Alright, because 6 can divide by 2 gives me 3. I cannot divide 2 with 5 or 15. Alright, so next will be 3. Okay, I want to bring this one down to 1. This one I cannot, but I can divide 15 by 3 because that gives me 5. See that? Now I can divide 5. This becomes 1, this becomes 1, and this already was 1. Just bring it down. See that? Now I multiply. And that should be my common denominator for all these three. So 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60 from our timetable. Okay? This is in our timetable range. That's why Mr. Mac kind of doing like this. If it's outside our range, we use the long multiplication method. Okay? Okay, so 2 times 2 is 4, 4 times 3 is 12, 12 times 5 is 60, okay? So that means 60 is the common denominator for all these three. Now ask yourself, how do I go from 30 to 60? I multiply that by 2, okay? If I multiply this by 2, 30 times 2 give me 60. That means what I do? Multiply the numerator also by 2, okay? So that means I take 23 times 2. 2 times 3 is 6, 2 times 2 is 4. So that gives me 46. So that's 46. Now how do I go from 5 to 60? Exactly, 12 times 5 is 60. That means I'm multiplying this by 12. See that how important to have a very strong timetable? The moment I ask you 5 times what gives me 60. Alright? So which is 12 times 5, okay? So that gives me, that means if I times the denominator by 12, I have to do the numerator also by 12. 4 times 12 is 48. 48. Okay? Now how do I go from 12 to 60? Exactly, I multiply that by 5. 12 times 5 is 60. If I multiply 12 by 5, I also have to multiply 7 also by 5. The numerator also has to be times with the same number that you times the denominator. Keep in mind, that's the key, okay? That's the key. Numerator and denominator, either you multiply or divide the same number. You don't discriminate, okay? This is called non-discrimination method, alright? How about we do that? We call it non-discrimination method. Alright? If you multiply this by 2, you got to multiply that by 2. Okay? So, in other words, let's say use a different word. How about fair game, fair, okay? Be fair, be fair method. Alright, be fair. That's a good one, okay? Be fair. If you multiply 2 the denominator, you be fair. Also multiply 2 with the numerator. Alright? Okay, good. That's a good one. Alright. So, we multiply 12 by 5 gives me 60. That means 7 times 5 is 35. Now, can I arrange them now? Definitely, because they all has the same denominator. So that means now I can tell which one is the smallest, because we're going the increasing from the smallest, okay, which would be what? 35. Make sure you bring the denominator with it. And then what's the next one? Between these two, 46. And of course, and this will be the last one. If this helps you to cancel it, you put it down. So now you know this two. Then once you put it down, that's the left. Bring it down. If that helps you, okay? Alright. Pretty easy, isn't it? Very straightforward. And, you know, the reason it's so easy is because you're working so hard. You're paying attention to Mr. Mac as I'm teaching. And you're practicing on your own. When I tell you it's time for hands-on practice, you're taking the initiative. That's what makes you special. There's a giant in every one of us. Sometimes, to some student, the giant could be sleeping, but to you, the giant is awake. Why? Because you're so motivated. You want to do good in your school. That's why you're here. If you're not motivated, if you don't want to do well in your school, you wouldn't be sitting right now in front of your computer and watch Mr. Mac's teaching and practice on your own. And you're going to take your quiz as well after this. That's what makes you special. That's what makes you score a math victory student. And you are Mr. Mac's proudest student. And I'm very proud of you. Alright, there you go, Pablo. He said, Mr. Mac, it's time for quiz. And then what he's going to do? He's going to dare us. I dare you. That's good. He's challenging us because he wants us to do the quiz. Okay? Alright, my dear students. Mr. Mac always cares about you. And that's why I'm here to bring the best. Okay? Alright, go get them. Go have fun with the quiz and then come back and see me on the next sub lesson. It's going to be fun. It's going to be more exciting than the last time we're going to learn. Alright? Bye-bye. See you soon. Bye-bye.